Lesson 4:4, Parallel and Perpendicular Lines. Our essential question today is how do you write the equation for a line parallel or perpendicular to a given line through a given point? So we're writing an equation for a new line that is either parallel to the given line or perpendicular to it, and it has to go through a specific point that's given. Okay, our first example says write an equation in slope-intercept form for the line that passes through the point 3, 1 and is parallel to the graph of y equals 2x plus 1. I'm going to show you what this looks like on the graph, and I'm going to show you how to solve it using algebra. So our original line is y equals 2x plus 1. So on my graph, y equals 2x plus 1 starts at my intercept of 1, and then the slope is 2, so I'm going to go up 2 over 1. Up 2 over 1, and then draw my line. The new line has to go through the point 3, 1 right here. So this is my original line, y equals 2x plus 1. And now we have the point 3, 1 that has to be on my new line. And my new line has to be parallel to the original. Well, we learned that parallel lines have the same slope. So my new line has to have the same slope as the original line. So that means that the slope is going to stay 2. So y equals 2x plus 1 has a slope of 2. My new line will also have a slope of 2. So from my point 3, 1, I can go up 2 over 1 and draw my line. So this is what my line is going to look like. It's parallel to the original line, and it goes through that specific point 3, 1. Now to use algebra to solve this, I can use point slope form, and I can plug in what I know. I know the ordered pair is 3, 1, so that's x1 and y1, and I know my slope is 2, so that's m. So y minus 1 equals the slope times x minus x1. This is what my equation would look like. So again, I substituted 3 and 1 from the ordered pair. I substituted those into x1 and y1, and then I substituted the same slope 2 for m because parallel lines have the same slope. Now I can solve this and get y minus 1 equals 2x minus 6, and then add 1, and my solution is y equals 2x minus 5. So my new line that I've graphed over here, if I extended my line 1, 2, 3, 4, 5, it would go through right here. If I extended my line, it goes through negative 5. That's my intercept. So that looks correct. So y equals 2x minus 5 is parallel to y equals 2x plus 1, and it goes through the ordered pair 3, 1. A second example like this, slope-intercept form again, it has to pass through the point 4, negative 1, and it has to be parallel to 2x plus 3y equals 6. Now this one's going to require more work from me because I can't tell what the slope is by looking at this equation. So I need to rewrite my equation into slope-intercept form first. So subtract 2x on both sides. So 3y equals negative 2x plus 6. Remember to put that in slope-intercept order. So that's why I'm not writing 6 minus 2x. You want the negative 2x and then the positive 6. The next step is to divide everything by 3 because slope-intercept form means y equals, so we have to have the y by itself. My slope is negative 2/3 and my intercept is 2. So on my graph, this one would start at 2 and then go down 2 over 3. Down 2 over 3. Like that. Now my new point that it has to go through is 4, -1, which is right here. So this is pretty close together. So my new point, and then I use my slope. I use my slope from the original line, so I could go down 2 over 3, down 2 over 3, and draw my line. They're parallel and they're super close together. To get my equation though, I want to use point slope form and solve it. So y minus -1 equals my slope times x minus xy. Okay, y minus 1, or y minus -1, sorry, turns into a chunky plus. And then I need to distribute my slope. So -2/3 x and -2/3 times -4, I can put a 1 under it, would be 8/3 or 2 2/3. 2 2/3. Okay, now I subtract 1 on both sides. And y equals -2/3 x plus 2 2/3 minus 1 would be 1 2/3. So that is my answer. My equation has the same slope as the original, -2/3, and if I continued my line right underneath here, my original intercept was +2, so this one is a little bit lower, so it ended up being 1 2/3. You would not have been able to figure out that intercept by graphing alone. The algebra is required because the intercept is not an integer value. So it's important to have the algebraic way to solve it, not just rely on the graphing, because you don't always have slopes and intercepts that are nice numbers. Okay, now we're switching over to perpendicular. So write an equation in slope-intercept form for the line that passes through -2, 3, and is perpendicular to the graph of y equals 1/4 x plus 7. So I'm going to graph this line first. There's 7 on the y-axis, and up 1 over 4, up 1 over 4, draw my line. So this is my original line. And then the new line has to go through -2, 3, and it has to be perpendicular. Perpendicular slopes flip and change. Perpendicular slopes flip and change. So two things are happening when the lines are perpendicular. The original slope is 1/4 here. I have to flip it over, so that's the reciprocal, and change the sign. So my new slope is -4. So I can graph my line. My new slope is -4, so down 4 over 1, down 4 over 1, and draw my line like that. Now on this one, I could get the equation from the line. I'm going to show you the algebra though. So we're going to use point slope, just like the last ones. The difference is we are going to just be careful and make sure that we change our slope. So y minus the y coordinate 3 equals my new slope, which is -4, times x minus -2, which turns into a chunky plus. So the important part is to make sure that you are remembering to change this slope. Change the slope. Don't keep it 1/4. Perpendicular slopes flip and change. Parallel slopes stay the same. Distribute -4 and you get -4x minus 8. Add 3. And you get -4x minus 5, which is exactly what my line looked like when I graphed it. So sometimes graphing works out that you could get your equation from the graph, other times it does not. All right, one more example with perpendicular, and this one's going to require a little bit more work. So the original line, we cannot see the slope, so we need to solve it to figure out our slope. Subtract 3x on both sides. Bring down the negative 2y, and it's equal to negative 3x plus 6. Keep it in slope-intercept order. And then divide everything by negative 2. The slope reduces because a negative divided by a negative is a positive, so it reduces to positive 3/2 x, and then the intercept, 6 divided by negative 2 is negative 3. So start at negative 3, go up 3/2, and draw the line. The new point is negative 4, negative 5. So down here. So my slope has to flip and change. So take that slope, flip it over, change the sign. So my new slope is negative 2/3. And my ordered pair, I can plug in for x1 and y1. So y minus negative 5 equals my new slope, negative 2/3, times x minus negative 4. These are both chunky pluses. Distribute and solve. So negative 2/3 x and negative 2/3 times 4/1 is negative 8/3, or negative 2 2/3. I subtract 5 on both sides, and both of those are negative, so it's negative 2/3 x, and then negative 2/3 minus 5 more would be negative 7 2/3. So, looking at my graph, my new slope was negative 2/3, so if I go down 2/3, down 2/3, you can see that it doesn't cross. It doesn't cross at, move it a little bit, doesn't cross right on the grid lines. So if you come to see where it crosses, 7 2/3, negative 7 2/3 does make sense. It does make sense. And I could extend my blue line a little further there to see that they are perpendicular. You should be able to write a summary now. Make sure that you use complete sentences and restate that essential question in your summary.